Hello students, today we are going to discuss uniform distribution. This is one of the important distribution in your studies. Today the following topics to be discussed. First one is objectives of the distribution, introduction, discrete uniform distribution definition, properties of uniform distribution, mean and variance, moment generating function, probability generating function, characteristic function and few examples, followed by summary of this particular distribution. So, what are the objectives of this uniform distribution? After studying this unit, you will able to find the probability mass function of discrete uniform variate, its mean and variance, its moment generating function and characteristic function of the uniform distribution. So, basically after studying this unit, you should be able to apply many things in your daily life also. So, that means after studying this unit, you should be able to find probability mass function as well as many applications of this distribution. Now, introduction of this uniform distribution. When the different events associated with an experiment have an equal chance of occurrence, we find the application of discrete uniform distribution. Clearly mentioned here, when the different events associated with an experiment have an equal chance of occurrence, we find the application of discrete uniform distribution. For example, if a symmetric or fair dice is thrown, then all the 6 faces having the equal chance to win. All the 6 faces have to equal chance to win. So, discrete uniform distribution, definition of discrete uniform distribution. A discrete uniform random variable, a discrete random variable x is said to have the uniform distribution on integers 1, 2, 3 and so on up to m. If its probability mass function is given by, P of capital X is equal to small x is equal to P of x is equal to 1 by m. X takes the values 1, 2, 3 and so on up to m. Otherwise, that values goes to 0. Therefore, what is the probability mass function of uniform distribution? P of x is equal to 1 by m. 1 by m is the probability mass function of the uniform distribution. For example, when a fair dice is thrown, if x is denotes the number that turned up, then probability of x is equal to small x is equal to 1 by 6. Why 1 by 6? Any number you can choose. A dice is having 6 faces, all are equal chances, then we will get x takes the values where to where 1, 2, 3 up to 6. Therefore, what is the probability mass function? 1 by m. Now, if any number is taking, that is probability of x is equal to 1 by 6. Any number will get turn up, that is equal chance. So, getting of x is equal to 1 is also 1 by 6. Getting of 6 is also equal, that is 1 by 6. Therefore, we can say that is why this is a equal chance of getting, that is why we can apply uniform distribution probability mass function to obtain the probability of x is equal to this particular value. Properties of uniform distribution. As we mentioned earlier, so now after definitions we are going to discuss a important properties of uniform distribution. What are the important properties of uniform distribution? Like we can find mean and variance of uniform distribution, moment generating function of uniform distribution, characteristic function of uniform distribution, like this. Okay. First we are going to discuss first properties of uniform distribution is how to find the mean and variance of uniform distribution. So, mean and variance of uniform distribution, if x has a uniform distribution on the integers, takes the values 1, 2, 3 and so on n, 1, 2, 3 and so on n, then its first moment about origin is mu1 dash is equal to expectation of x, take x is equal to 1 to n, just now we define what is the range of x, x is equal to range of x is equal to x takes the values 1 to n, x into P of x, where P of x is equal to what? Probability mass function of uniform distribution. So, what is the probability mass function of uniform distribution? P of x is equal to 1 by m. P of x is equal to 1 by m. Now, we can substitute the values. Integers what? The uniform distribution is numbers 1 to n, then its moment generating function is what? 1 by n of 1 plus sum of the n natural numbers, that means what? 1 plus 2 plus and so on up to n. So, we know that 1 by n of n 1 plus n plus 1 plus 2 plus and so on n, that is equal to, on simplification, after simplification of these terms, we will get n plus 1 divided by 2, n plus 1 by 2. So, that is what is that? Mu 1 dash, mu 1 dash is equal to, first mean mu 1 dash is known that what? Mean of the uniform distribution. Therefore, mean of the uniform distribution is n plus 1 by 2. Now, the second moment about origin is, because we would like to find the variance of the uniform distribution. That is why second order moment is required for to obtain the variance of the uniform distribution. For that, what I am doing, I can find out the, first I can find out the mu 2 dash value. What is the mu 2 dash? Mu 2 dash is equal to expectation of x square, summing over x is equal to 1 to n x square into p of x, where p of x is what? Already you know that p of x is probability mass function of uniform distribution. So, 1 by n of summing of what? X square, expand this summation, p of x is equal to what? 1 by n, that is a probability mass function of the 1 by 10 is a constant taking outside, then expand this x square, 1 square plus 2 square plus and so on m square. You know this, what is this? Sum of squares of the n natural numbers, 1 square plus 2 square plus and so on up to m whole square, that is n plus 1 of 2n plus 1 by 6. What is that? Mu 2 dash is equal to n plus 1 of 2n plus 1 by 6. Therefore, variance, you know that variance formula. What is the variance formula? Variance formula is equal to mu 2 dash minus mu 1 dash whole square, mu 2 dash minus mu 1 dash whole square. Okay. So, now already we are find out the mu 1 dash value and mu 2 dash value. Just now we find out the mu 2 dash value. What is the mu 2 dash value? N plus 1 of 2 n plus 1 by 6. What is the mu 1 dash value? N plus 1 by 2, n plus 1 by 2. Now, I can substitute mu 2 dash value and as well as mu 1 dash. If I substitute mu 2 dash, n plus 1 of 2 n plus 1 divided by 6 minus n plus 1 whole to the power of 2 by 4, that means n plus 1 by 2 whole to the power of 2 means n plus 1. This looks like about a plus a by b whole square. Then we can write a square separately and b square separately. Then I can write n plus 1 whole square divided by 2 square is equal to 4. Okay. So, then I can simplify this completed terms, n square minus 1 divided by 12. That is also we can write. Now, numerator term is looks like a which form? N square minus 1, this looks like a square minus b square. You know that what is the formula for a square minus b square? So, a square minus b square is equal to a plus 1 into a plus b into a minus b. So, just now I can apply that formula for this. N square minus 1 is also I can write n plus 1 into n minus 1 divided by 12. So, this is the variance of the uniform distribution. This is the variance of the uniform distribution. Okay. So, now you are identify the mean and variance of the, now you know what is the mean of the uniform distribution? Mean is equal to n plus 1 by 2 and variance is equal to n square minus 1 by 12 or n plus 1 of n minus 1 by 12 is the mean and variance of the uniform distribution. That is the important property of uniform distribution. Now we are going to discuss one more important property of uniform distribution, that is moment generating function. So, what is a moment generating function? How to find the mean and variance of that particular distribution? So, now before identify these things, now I can define the, first we would like to define the moment generating function first. So, if x has a discrete uniform distribution, if x has a discrete uniform distribution over the integers range from where to where? 1 to n, then its moment generating function is given by then its moment generating function is given by. So, moment generating function is defined as which notation? Moment generating function, first letter is what? M. So, we can represent it by M only. F of what? X is a variable that we can write as suffix M suffix of x of function is in terms of t, that is mx of t. Mx of t is equal to expectation of this. E means what? Expectation of e to the power of tx. That we can apply in terms of summing over expectation of e power tx is equal to what? Summing over x takes the values 1 to m e power tx into p of x, where p of x is equal to what? P of x is the probability mass function of uniform distribution. So, instead of p of x I can substitute 1 by n. 1 by n is the probability, as you know, that is already you are aware of these things, already very beginning we defined this probability mass function. The probability mass function of uniform distribution is 1 by n. Now, we can expand the summation. 1 by n is the independent from this summation. We can take outside of this summation. After that, we can expand this summation. Summation is applicable for whenever the x is there, instead of x you can summing over that term is expanded here, substitute that value. Okay. So, x takes 1 by 10 is a constant taking independent term, that is taking out of our summation. Then immediately after that I can expand the summation. X takes a values 1 to m. First, for example, if I take x is equal to 1, e power tx becomes what? E power t only. If I take the second term is what? 2. If I substitute instead of x is equal to, it is goes to e power 2t. Similarly, can go for up to how many terms? M terms. Then e power t plus e power 2t plus e power 3t plus and so on plus e power mt. So, now it looks like which expansion? One expansion form, exponential expansion form this. So, 1 by n of e power t is taking outside. If e power t is simplified, then we will get 1 minus e power nt divided by 1 minus e power t. After simplification that we can write, that is also we can write in terms of e power t, then this e power t is go inside, then we can write e power t minus e power t into e power nt. So, bases are equal here, power should be added. So, what is the constant term here? T is the constant taking outside, e power e to the power of n plus 1 of t also we can write divided by n of 1 minus e power t. If t for t is not equal to 0, for p is not equal to 0. So, using the above value also, if you do the differentiation with respect to t and put t is equal to 0, we will get first order, second order of that particular moments of the uniform distribution. Next, we can go for probability generating function. Probability, next important property is probability generating function of uniform distribution. When x has discrete uniform distribution over the integers 1, 2, 3 and so on n, its probability generating function is. So, generally probability generating function, probability generating for probability first letter is p, we can represent it by p of s, s is the function here. So, probability of s is equal to expectation of e to the power of expectation of s to the power of x, s to the power of x. Summing over x takes the values where to where according to your question. Here x takes the values 1 to n, s to the power of x into its probability mass function. What is the probability mass function of uniform distribution? 1 by n. So, here again similarity, here 1 by x is independent from, free from this summation, 1 by n is free from this summation, this 1 by n is taking outside of your summation. If after that you can put wherever the x is there, instead of x you can substitute 1, 2, 3 and so on up to n terms, then we will get s. If I substitute x is equal to 1, s to the power of 1, if I substitute expand x is equal to 2, then it becomes s square. If I take expand up to n terms, then it becomes s to the power of n. Okay. Now, s plus s square plus and so on up to s to the power of n. this we can write 1 by n of S is taking outside, then again we can write it's again 1 minus n s to the power of n divided by 1 minus s. So, that s is coming inside of your function 1 by n of s into 1 is s minus s into s to the power of n divided by s minus 1. Again this s into s minus 1 becomes what? Bases are equal, power should be added. S to the power of this becomes what? S to the power of n plus 1. For s is not equal to 1, then only this function is defined, otherwise that value goes to 0. That is why s is not equal to 1. S is not equal to 1. This is the probability generating function of the uniform distribution. So, next one is, next important property is characteristic function. If x has discrete uniform distribution over the integers 1, 2, 3 and so on n, then its characteristic function is. So, characteristic function is denoted by phi of x, x is a suffix value here, t is a function in terms of that particular function. Pi x of t is equal to expectation of e to the power of itx. If it is mgf, you can write mxt, but instead of mt e to the power of tx, we can substitute itx. If it is itx, then it is the characteristic function. If it is tx only, then it is moment generating function. Just you have to identify, these are the two important differences. Okay. So, now I can expand this definition as per definition of mathematical expectation. Summing over x takes the values 1 to n e power itx into its probability mass function, where p of x is equal to what? Probability mass function of which distribution? Uniform distribution. What is the uniform distribution probability mass function? That is 1 by n. Again here also same thing is applicable here. 1 by n is free from, independent from this summation, that is taking outside of summation. If I take 1 by n is taking outside of our summation, then we can go for expand this e to the power of itx expansion form. So, if I take x is equal to 1, e to the power of t means what? E to the power of ix and e to the power of i2x and so on like this, then here we can apply here 1 by t. After simplification of this expansion form, we will get e to the power of it minus e to the power of it of n plus 1 divided by 1 minus e to the power of it. Same expression already we derived in terms of moment generating function also. So, just you have to compare with that expression and this expression. Only thing is, only changes are what? Instead of t, we can get it. Wherever the t is there, instead of t, we are obtain, especially in this characteristic function, that is it. Here, if this function, when this function is exist for t is not equal to 0. If t is equal to 0, this function is failure, you are not define anything. So, that is why our condition for characteristic function of this function is 1 by n of e power it minus e power it of n plus 1 of 1 minus e power it is the characteristic function of uniform distribution. So, after getting the probability characteristic function, we go for next few example problems here. That example problems are, for example, I can give 1 or 2 example. In that case, a telephone number is selected at random from a directory. Suppose x denotes last digit of selected telephone number. Find the probability that last digit of the selected number is maybe 6, less than 3, greater than or equal to 8, greater than or equal to 8. So, now for example, if I go for this one, how to identify the solution? So, for example, let x denote what? Last digit of the randomly selected telephone numbers. What are the possible values of x are? Number digits are what? Start with where to where? 0 to 9. What are the possible values of x here? 0, 1, 2, 3 and so on up to 9 only. all the numbers are equally likely. That means getting of 0 is equal chance, getting of 9 is also equal chance. That is why we can use the word equally likely. Thus, the random variable x follows uniform distribution u of 0, 9, because low number start with what? 0 to 9. The probability mass function of x is, so what is the probability mass function of x is equal to 1 by 9 minus 0 plus 1, then it becomes 1 by 10. So, getting of any number is equal to 1 by 10 only. That means x takes a values where to where? X is equal to 0, 1, 2, 3 and so on 9. Therefore, first question is what according to our problem? What is the probability that the last digit of the selected number is 6? The probability of that last digit of selected number is 6. What is the possible chance? That means probability of x is equal to 6 is equal to what? 1 by 10 only. 1 by 10. So, that means 1 by 10 is equal to what? If you simplify 1 by 10, it becomes 0.1. So, what is the chance of getting 6 is equal to what? 0.1. You can check other numbers also. If I go for example, my number is 9. The probability of that last digit of selected number is 9, for example. That is also 1 by 10 only. That means that is why you can take equal chance. Getting of 0 is 0.1, getting of 2 is 0.1, getting of 3 is also 0.1, getting of 9 is also 0.1. So, that is the first answer. I think you are understanding the first bit. So, now coming to second bit, what is the second bit here? The probability that the last digit of the selected telephone number is less than 3. Less than 3. So, less than 3 means, what is the less than 3 means? What you can write? That is probability of x less than 3. Probability of x less than 3 means what? Probability of that may be x is equal to 0 plus adding probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 only. Less than 3, strictly they say less than 3. That means probability of x is equal to 0. Just now I said, what is the probability of getting a x is equal to 0? What is x is equal to 1? Probability of x is equal to 2. So, probability of x is equal to 0 is 1 by 10. Probability of x is equal to 2 is also 1 by 10. Probability of x is equal to 1 by 10. Add these 3, 1 by 10 plus 1 by 10 plus 1 by 10. How much this? 0.1, 0 plus 0.1 plus 0.1. Then it becomes 0.3. So, therefore, what is the probability that the last digit of the selected telephone number is less than 3 is how much? 0.3 is the answer. Okay, one more bit is there. What is that? The probability that last digit of selected telephone number is greater than or equal to 8. So, that means what? Probability that the last digit of the selected telephone number is greater than or equal to 8. That means how to write in terms of notation? That is probability is x is greater than or equal to 8. That means what? Probability of x is equal to q plus probability of x is equal to probability of, that means what is the probability x greater than or equal to means probability of 8 plus, we can write probability of x is equal to 8 plus probability of x is equal to 9. Then we can write what? 1 by 10. Probability of getting all the numbers are equal chance only now. Whether it is 9, whether it is 8, whether it is 6, whether it is 7, all are equal chance. Then we can write instead of probability of x is equal to 8, we can write 1 by 10. Probability of x is equal to 9 is, we can write 1 by 10. 1 by 10 plus 1 by 10 is equal to how much? So, it is 0.1 plus 1 by 10 plus 1 by 10 is equal to 2 by 10. So 2 by 10 is equal to 0.2. So, what is the chance? What is the probability of the number is greater than or equal to 8? That is 0.2 chance only. Now, I go for one more example problem. That is the random variable x has probability mass function given by probability of x is equal to k, where x takes a values here 4, 5, 6, 7, 8, where k is a constant. Find the value of k and find the mean and variance of the distribution. Okay. So, we know that Sum of the probability is always 1 only, na? So, that is we know that is very familiar condition and important condition, everyone knows that is. Okay, there we know that sum of the probability mass function is equal to 1. So, summing over what are the variable values here? X takes the values where to where? X is equal to 4 to 8, that is probability of x is equal to 1. Then we can write probability of summing over x takes the values where to where? 4 to 8. Probability of x is equal to 4 plus expanded up to 8. That means probability of x is equal to 4 plus probability of x is equal to 5 plus probability of x is equal to 6 plus probability of x is equal to 7 plus probability of x is equal to 8 is equal to 1. But we know that probability of x is equal to whatever the number, that is what is the representation according to your problem already is given. The probability mass function is equal to k. Therefore, you can write x is equal to 4 is also k plus if it is 5 k, if it is 6 also k, if it is 7 is also k, then adding all the k's 1 k plus k plus k plus k plus place. How many k's here? 5k. 5k is equal to 1. Then we can find what is the value. First question is what? Find the value of k. Therefore, value of k is equal to 1 by 5. So, mean of that particular mean is equal to what here? Expectation of x. Expectation of x is equal to mean. Mean is equal to what? Summing over x into probability of x is equal to small x. That is, so expanded up to already just now we did na, x is equal to 4 to 8, x into probability of x is equal to 8, that is 4 into k plus 5 into k plus 6 into k plus 7 into k plus 8 into k, that is 30k. But k already we know that. What is the k value? K value is equal to 1 by 5. Therefore, your mean is equal to 6. Now, we can find variance. What is the variance formula? So, already mean variance is equal to what? Summation of x square into probability of x is equal to x minus mu square. That is equal to, already we find out the mean value, then we can find out mean variance is equal to what? Mu 2 dash minus mu 1 dash whole square value. Already we got mu value, mean of the function is 6 and we can find expectation of x square into probability of x, that is equal to 190k. So, therefore, variance of x is equal to 2. Variance of x is equal to 2. But we know the formula also. What is the formula? N square minus 1 by 12. What is n value? 5 square minus 1 by 12 is equal to 2. Now, from this I can conclude some summary. For conclusion of this session is, the summary of this uniform distribution is, the uniform distribution, the discrete uniform distribution can be used to in situation when the events are having equal chance of occurrence. That is the first summary point, foremost. So, when x has a uniform distribution over the range 1, 2, 3 and so on, mean is equal to n plus 1 by 2 and variance is equal to n square minus 1 by 12. The moment generating function is mxt of t is equal to e power t minus of e to the power of n plus 1 of t divided by n of 1 minus e power t for t is not equal to 0. The probability generating function is equal to 1 by n of 1 s to the power of s minus s to the power of n plus 1 by 1 minus s for s is not equal to 1, and the characteristic function is equal to pi of x of t is equal to 1 by n of e power I t minus e power I t of n plus 1 minus by 1 minus e power t. Thank you all for listening this. Any doubt, any queries, then ask your mentor to contact to @ of given mail IDs. Thank you all.